Hello everyone. This video continues the previous lesson that we did on Introduction to Indefinite Integral. So let's go back and quickly review to everyone what we have done. So we learned about the definition of integral, all the terminologies. We also learned about the basic formulas of the integral of x raised to a power. I would like to remind everyone that this formula only applies when you have n is not equal to -1. So obviously, if you take -1 add 1, it turns into a 0. You cannot divide it by 0, okay? Because divided by 0 is undefined. Then we went over a few examples of the very basic function. We raise x to certain power. At the same time, we remind ourselves of converting between radical and exponent. We also learned the properties of indefinite integral to find integral of a sums or difference of different functions. Then when we can break the function into individual functions, and then we go from there. If we have a function multiplied by a constant, then what you can do is before you integrate, you can bring that constant across the integral sign to simplify the process. Alright, so we finished question number 5. In this question number 5, I emphasize to everyone that the square root of x is a function, is not a constant. So what you need to do is, because you have a binomial here, you multiply by the binomial, you can distribute by multiply square root of x inside each term of the bracket, then convert to exponent, and then we go from there. Alright, okay. So let's start with question number 6. In this question, you see that it's quite a few functions that we have. We have -3 times square root of x, -1 over 2, times cube root of x, plus 5 cube root of x divided by x squared. So many of us probably get confused of the cube root of x divided by x squared. In fact, it's actually very simple. You just have to perform the basic operation of exponent, and then we go from there. Okay, so this question asks us to at least simplify our integrand before we can integrate. So let's get started. Okay, so I also want to use this opportunity to remind everyone that before you integrate, you simplify the operation, and then you still have to leave the integral sign in writing the next line. So if I write the next line, I will write it as the integral of, okay, so you can see that I will break this into individual integrals. So I will break it into 3 integrals. At the same time, what I will do, I will bring the constant across the integral sign. Okay, so I bring the constant across the integral sign. I will convert this into the exponent, and then I simplify whatever I need to simplify. So for this first one, what I'm going to do is I'm going to bring the -3 across the integral sign. Okay, at the same time, you see that the square root of x, I can raise that to x to the exponent a half and dx. Okay, my next step is to break this into the another integral as well. So I will bring -half across the integral sign, and inside the brackets, I will write x raised to the exponent -1/3. Okay, and don't forget the dx. The next step is to write plus, bring 5/4 across the integral sign, and inside the brackets, you can see that you will have a cube root of x. Okay, and I can write this as x to the exponent 1/3, x to the exponent 1/3 divided by x squared dx. Alright, okay. So now you take a look at this integrand. So this integrand, what you can do is you can simplify this by taking 1/3, subtract 2. Okay, so I want to remind everyone of these formulas. If you divide two powers with the same base, what you can do is you can subtract the two exponent. Okay, so what I have done here is I will take 1/3 and I subtract 2. So 1/3 subtract 2, what do we get? So 1/3 subtract 2, I should have the answer as -5/3. Okay. Okay. So I just want to leave it on the side for everyone to see. 1/3 minus 2 will give me -5/3. Okay. Then I will have cube root of this. I mean -3 times x raised to the exponent a half. Okay. This one I will have x to the -1/3 dx, and this is 5/4, and the integral of x raised to the exponent -5/3 dx. Okay, so the next step is to add 1 to the exponent and then divide it by the result. So I want to make a quick review here. So I have +1. Okay, this one I should have -1/3 plus 1. This one I should have -5/3 plus 1. So a half plus 1, okay, a half plus 1 will give me 3/2. Okay, -1/3 plus 1, this should give me 2/3. Okay, -1/3, 5/3 plus 1, -5/3 plus 1, I'm sorry, will give me -2/3. Okay, so just make sure that we have all of this exponent here on the side. That means I will have -3. Okay, and what I will do is I will show everyone how to do this. So it will be x raised to the exponent 3/2. At the same time, I divide it by 3/2. It means I multiply by 2/3. Okay, so that's how I write this to simplify my writing all the step down. So in this case, I should have x raised to the exponent 2/3, and I divided by 2/3. It means I multiply by 3/2. Okay, so here's 5/4. The x raised to the exponent, I should have written here as a bracket as well. Multiply by, so this is x raised to the exponent -2/3. At the same time, I divided by -2/3. That means I multiply by -3/2. Okay, so double check we are good. Make sure that we have to add the c, and now we can simplify. Okay, so this will give me that, cancel that, so I should have -2 x 3/2. This one should give me 3/4 x raised to exponent 2/3. This one I should have -15/8 x raised to the -2/3 plus c. But the question asked me to write everything as positive exponent. Therefore, we just have to write one more step. 3 subtract 15/8. Okay, so in this case, you are going to write x as a denominator, and then you raise to the positive 2/3. Okay, so this will be plus c as the final result. Okay, another formulas for everyone is a to the negative n. You can write it as 1 over a to the positive n. Okay, so you take away the negative sign, you divide the entire power into 1. Alright. Okay. Very good. Alright, so let's move on to the next question. Okay, so this question number 7. Okay, again, it's involved a few algebra again with all the radicals, and we have to subtract, we have to convert, and then we can subtract the exponent. So what I'm going to do is I will break this into individual integrals first. So negative 9 x to the exponent 3. Okay, so I'm going to do this step by step for everyone. And then I add this with 5x squared. Okay, q root of x. So all of this is dx. Okay, so what I have done is, because I divided by the denominator of q root of x, so what I can do in this case is I should break this into two fractions as the integrand. So negative 9 square root of x cubed divided by q root of x plus 5x squared divided by q root of x. So the purpose of this question is to remind everyone that this is the square root of x to the exponent 3, and this one the q root of x raised to the exponent 1. Okay, so the next step is to break this into two integrals. Okay, two integrals, and at the same time I will bring the constant across the integral sign, and at the same time I will simplify the two powers x with the same base. Okay, so what we have to write next is I will break this into negative 9 times the integral of q root x to the exponent 3, and then the square root, so that means it will be x raised to the exponent 3 over 2. Okay, so it will be x raised to the exponent 3 over 2. Okay, so at the same time I want to remind everyone that this is x raised to the exponent 1/3, and here's dx. So plus 5 brings 5 across the integral sign. I will have x squared divided by x raised to the exponent 1/3, and also dx. So now I will perform the operations of, if I divide the two powers with the same base, I can subtract the two exponents. So you can take 2/3 subtract 1/3. You can take 2 subtract 1/3, but you haven't integrated yet. Okay, you should just simplify the integrand. So you still have to write the integral symbol here. So I have x 3 over 2 subtract 1/3 plus 5. This is x squared subtract 1/3 dx. Okay, so this one I should have negative 9, and 2/3 3 over 2 subtract 1/3 will give me 7 over 6 dx. Okay, plus 5 integral of 2 subtract 1/3, I should have 5 over 3 dx. Okay, so now I will remind everyone that 7 over 6 plus 1 will give me 13 over 6. Okay, so it's 13 over 6. This one I should have 5 over 3 plus 1. I should have 8 over 3. So this is the exponent that we found. Then now we are going to integrate. Integrate, you're going to take away the integral and the dx sign. So we have -9. Okay, so here I raise x to the exponent 13/6. It means I divided by 13/6. Then I multiply by 6/13. Plus 5. X raised to the exponent 5/3. It means I multiply by 8/3. I'm sorry. Okay. So this should be 8/3. Okay. So that means I multiply by 3/8. Alright. So all we have to do next is just simplify and make sure that we add the c. And the next step is to write it as -9 times 6. So -54 divided by 13 multiplied by x raised to the exponent 13/6. This one I should have 15/8 times x raised to the exponent 8/3 plus c. Okay. So let's double check everything that we've done. Okay, again, just want to remind everyone that right at this step right here, I would like to remind everyone this step right here. Okay, so what you do is you just subtract the exponent, right? So you simplify the process by these two. So you subtract the exponent right here, subtract the exponent, and you haven't integrated yet. This is to simplify your integrand. So when you simplify your integrand, you simplified it to x raised to a exponent, x raised to an exponent, right? Then after that, once you have just x raised to an exponent, you can go ahead and integrate by add 1 to the exponent and then divide it by the result. Divided by the result as a fraction, it means that you multiply by the reciprocal. So in this case, 7/6 plus 1, I have 13/6. It means x raised to the exponent 13/6. Divided by 13/6, it means I multiply by 6/13. Okay, so for this integral, I have 5/3 plus 1 is 8/3. So x raised to 8/3, it means that I will multiply by 3/8. So at the end, we simplify our final answer. And the exponent for x is already positive, so we can leave our answer like this. Okay, so basically this question is asking you to be very careful. It looks complicated, but it's actually very simple by just performing a few algebraic operations for exponent and adding and subtracting fractions. Okay, so how about number 6? Okay, number 6 is in fact break them into individual integrals. At the same time, bring the constant across the integral sign, and then you simplify your integrand if you need to. You convert your radical into your exponents right here, and then after that you start performing the integration by taking your exponent at 1. Okay, so I just want to double check all our fractions here. So we have a half plus 1, that will be 3/2. Okay, and then we will have -1/3 plus 1, so we have 2/3, and we have -5/3 plus 1, so we would have -2/3. Okay, so then we are adding this with 1, adding this with 1, and we make sure all exponents are correct. Alright, okay, thank you everyone. I also want to remind everyone that at the end of this lesson, I only ask everyone just to do one homework question right here.